Okay, 1-3, almost done with the first chapter. Now we're going to talk about how you can collect your data. We're going to do 4 main types here, and then we're going to expand on one of the 4 types. It's probably the most commonly used for what we're going to be doing. But I think most of you have seen those words before: experiment, simulation, census, and sampling. You know, they're not that hard of words, right? So experiment, you've done them in chemistry and more investigations in biology, you know, dissecting and stuff like that. But you've done those. And what we talk about here, again, you can paraphrase this, it's some kind of treatment is applied to a part of a population, and responses are observed. There is then a second group that has to be the control group. The experiment that probably you're thinking of most is when they want to test new pharmaceuticals. They'll have one group that they give that we'll call it a drug or a pill to. Then they'll have another group that they give basically a sugar pill, or it's called a placebo. Okay, that's one very good example of how they do that. They see the results. Some people in the control group think that they're getting better, and they're then given sugar pills. And then because you don't know which one you're getting. Okay? That's a great example of an experiment. That's why they use the word treatment. Okay? Something, you know, could be shock therapy or something. But you do need a control group. If you don't have that, there's nothing to compare it to. And the responses here could be, you know, how are they reacting to that treatment? Okay, so that's an experiment. Simulation. Any ideas on that? Okay. You were going to raise your hand.
Just like taking a bigger experiment.
Yeah, probably the key there is fake. All right, because this is basically something that you could do, but it'd be a really bad idea to try it. Okay, or you want to kind of guess what's going to happen. A simulation is the use of mathematical or physical model, so fake, to reproduce the conditions of a situation or a process. You know, a good example there is, you know, you don't really want to be the person that has to test the effects of the atomic bomb. You don't want to be the person that's testing that personally. All right? It's not a very good job. Yeah. Well, so you would try and simulate that. You know, what would happen? And you can use models for that, obviously. I know you've heard the next word. Probably most commonly known by us is an attempt. You notice I use the word an attempt to get the population of the United States. But again, that's not perfect because census means you have to get a consensus, meaning everybody. Consensus in this case means everybody. A count or measure of an entire population. Remember, the word population in here truly means everybody. Could I get a census of this class? Yes, I could. We could find out, males versus females if we wanted to, and I could get everybody for this population. At least today I could. Maybe tomorrow somebody will be gone, and so I can't. What's that? Sometimes they just get mailed, and then people that don't send it back, they send somebody to your house, and it's a very long process. Not really. It really is. It's a couple of sheets of paper. You know, how many people you got living in your house? What are their ages? What are they? I mean, it's very simple stuff. And where do you fit for economically? And it's very simple questions. It's just people throw it out, or just don't do it. And so that's why it's very hard for the government to actually get a census. A couple years ago, that's why we're doing all the redistricting now, because they just did the census, and so they can redistrict. And that's for another class that you're taking that you can discuss. those types of things. And the one that you're probably most familiar with, sampling. And again, there's another S. All right. A count or measure of a part of a population which is where we're going to try and get our statistic from. Remember? Because a statistic isn't going to be everybody. It's just a sample. Okay. Phone surveys, probably a really good way of figuring that one out. They just get a sample. One that we're going to take a look at tomorrow is the Nielsen ratings. Does everybody know what that is? The Nielsen ratings? That's for television, internet, who's using it. They don't test everybody on that, all right? They just have some of the United States do that, and then they figure out, make a guesstimate of what the population would do using that sample. Used to be just television, but now we have so many forms of media they had to expand a little bit. So an experiment, simulation, census, and sampling. Any questions on the difference between the four? Again, sampling is the one we're going to talk about a little bit more as we go along. So that's the one that's more statistically based. So which of those four methods would you use to collect data for each of the following? A study of the effect of an asteroid colliding with Earth. Yeah, let's try the simulation on that one. That's probably a good idea. And with how powerful computers are nowadays, you can put a lot of information in there. They can compute it very quickly, and they can give you output very fast to find out what you think would have happened. How about number two, a study of the effect of aspirin on preventing heart attacks? Probably an experiment, but again, you remember what's so key about an experiment is that control group, okay? And without that, you're just kind of saying, well, it might work, I don't know. In experiments, you can find how powerful the brain can be over what you perceive. Even if you're getting that placebo, you know, oh, I feel great, no problem. A study of the weights of all linemen in the NFL. Is that something we could probably do? Yeah, that's probably a little bit easier than the entire United States, right? Because the population there is just the linemen in the NFL. That's not as bad. We can probably do a census on that one. I might have given this one away already. A study of Americans' approval rating of the U.S. president. Sampling. And that's that polling that they do, calling homes and whatnot. And it's a surprisingly low number that is used for that polling. That's why there's always a plus or minus so many points or percents on things like that. And we'll discuss that as we go on, why they chose that number and of people to ask, and it has more than to do just with statistics. So we'll see if you can come up with it. So any questions? Looks like you got those pretty well figured out. Pretty straightforward. Here's all the type of sampling you can do. So this is just sampling. We're not going to dive into the other ones all that much. This is just sampling basically being broken down into different types. Well, the first one says simple. That's got to be nice, right? Simple random sample. Well, so it's a technique where each member of the population has an equal chance of being selected. Doesn't matter if you live in Wild Rose or if you live in Seattle. If you're rich or you're poor. Okay? If you're Hispanic or Caucasian. Doesn't matter. You all have an equal chance of being selected. Remember, that's saying the population of the United States, but the population of this class would mean maybe me having a sheet of paper right there and just going, oh, there. That's who I'm choosing. All right, if it's a very random, you each have an equal chance, unless I put one of you in there twice. Maybe I put all your names in a hat. I pull out a sheet of paper. As long as you were all in there once, are all in there the same number of times, you have an equal chance. That would be a simple random sample. And then I would perhaps ask you a question. Who knows? Does that make sense? Okay. Stratified sample. So first, the members of the population are separated into groups with similar characteristics. So in here, it could be, oh, we'll put the males over there, we'll put the females over here. All right? Then a random sample is selected from each strata. So what's the strata in the example I just gave you? Right, it's the males and females, and what I have to do is a random sample from each strata. And normally it's best if you pick the same number from each strata. I don't want to pick, 4 females and then just 1 male. That's not a very good sample. And it doesn't have to be gender. It could be anything. Age sometimes is used. Where you live is sometimes used. But the key there is a sample is taken from each of the strata, meaning each of the groups. You can't just say, oh, males, I don't like you, you're over there, and we're just going to pick from the females over here. Right? That's not a very good sample, and it's definitely not a stratified sample. I believe that's called segregation or sexism. Well, these next two are a little bit more complicated. The last one's kind of spells it out for you, convenience sample. Cluster sample. So it's a naturally occurring subgroup. One or more, and I might want to add something in here, but not all. Okay? One or more, but not all of the subgroups is selected. Because if I pick all the subgroups, well, we're talking about something else. Each member for that group is used in the sample. So do you see the difference between a cluster sample and a stratified sample? Okay, here we have naturally occurring subgroups. So for example, I have 2 sections of geometry, hour 2 and hour 6. Those are naturally occurring subgroups of my geometry students, correct? All right. And we're going to choose one or more, but not all, of the subgroups is selected. So maybe I would just choose second hour, and I would take each member and use it in my sample. So all of second hour would get used in the sample, but I can't use sixth because here it says not all. Because you're going to use all, basically, isn't that your population? Okay, see, that's why they say but not all. Because what's the sense of having this if you're just going to pull everybody? Not with this one. Now, if I had 3 sections, like I did last year, I can't remember when they were, we'll say second, third, and sixth. I could take second and sixth and do all of them and keep third out. That's what the cluster, because if you use all 3 of them, I'm taking the entire population of geometry students. Okay, because think that's probably going to get used in a much bigger situation than what we're talking about right here. So they say, okay, you're over here, you're over here, you're over there, you're over there. I'm just going to pick these 2 and I'm going to get everybody. Okay? That's a cluster. If you think of that word, that's kind of how I think of. There's groups of things all over the place, and you just pick some of them. Okay, but you can do one or more, but do not do all, because then that's everybody. Yes. But then, what's your naturally occurring subgroup? No, that's almost more of the last one, a convenience sample. Hey, you're right here. I'm going to pull you. That's kind of what that is. Oh, hey, you're right here. I'm going to pull you. Oh, I'm not going to walk away over there and pull that person. That's too far. Oh, you're right here. I'm going to pull. You might be able to do that. That could be your naturally occurring subgroup. That's where I wanted to see where you were going to go with that. If I said, right, or maybe even say, okay, the people that work at Target versus the people that work at Sears, right? There's 2 naturally occurring subgroups, right? The employees there, or even just people in that store at the time. Okay, could be a naturally, because they chose to go there. It's naturally occurring subgroup. But to get all of them in Target, chances are somebody's going to leave by the time you get them, right?
You could bar the door.
Well, yeah, you could lock them in. Okay. Okay, just the people that work there or working there at that time. Sure, you could do that and go ask them, what do you think about this pizza joint over here? Be careful how you ask the question, but yeah, you could ask them for some data. It doesn't have to be little or more, right? So maybe you could do Target workers and Sears workers, but then leave, leave that other store out. Okay, exactly.
What if they don't have the same number?
Doesn't matter. Because naturally occurring might not work that way. Because even the geometry example I gave you, it's not the same number in each class. Yep. Good questions. But again, the key, naturally occurring, some but not all, because all is basically the population then, and that's wouldn't be a cluster. Systematic. This is definitely where a computer could definitely come in handy, is on one of these. Each member of a population is assigned a number. So in here, maybe you're 1 through 8. A starting number is randomly selected. That's kind of called the random seed, if you want to know what that's called. And then some formula could be made. It doesn't have to necessarily go this way. But then they'll say every nth person is selected. So maybe every third person, every fifth person. Okay. For example, let's say we have 200 people in this school, in the high school. Each one of you would be given a number, maybe 1 starting with the first freshman and 200 the last senior. And then somebody just picks a number, 47. And then from there, every maybe third person gets picked. With such a small population, though, are you necessarily going to get the demographic you want? Demographic meaning the split up of people. Because technically, could it possibly, if you do it that way, all end up males? It could. Okay. Could end up all people that are in the play. Could, it could. So that one's a little tricky. You got to be careful on that one. Bigger populations, though, that's a quick way of getting who you want to do it. That's kind of how they do the phone number thing. Oh, there's a number. Boop. I'll call that one. Yeah. Convenient sample, we kind of already talked about that. Available people, use them in the sample. Hey, you're here right now. I'm just going to use you. These all do get used, depending on how they want everything collected. Is one of the main reasons you would choose one over the other. And we'll do some examples as you see that you've got some on there. We'll see if you can figure out which one would be the best way to go.
How do you think that you like presidential approval, disapproval?
I would truly, in my heart, love to think they do a simple random sample. I'm not so sure that's the way. I guess it depends on who's running it. And they don't necessarily have to divulge that information. If a candidate runs the poll himself, the candidate may benefit from one or the other. Okay, and again, that's not necessarily something that, and even if it is divulged, how many people are really going to read it and know what that means? So you would like to think that it is completely simple random sample, but you have to be careful because they do have to have at least one strata that you have to be of voting age. So there is voting age and not voting age. So questions? I mean, because they could go to a convenience one and go to if they're a Republican, go to a Republican dinner and be like, oh, hey, all right, you're right here. I'm going to use you. So, gotta watch out. So what do you think? Class is selected at random, and each student is questioned. Okay, I heard cluster. A class. So is a class, like right now, if I walked into a room, that would be picking a class, right? Are those naturally occurring subgroups? Yeah. I mean, I could walk down the middle school right now and boom, well, let's just go in this room. Okay, so that'd be a bad example because they're not there, but they're at lunch. But Actually, no, they should be in class, aren't they? Yep. So yeah, that's a cluster. Number 2, the student population is divided with respect to majors, and some students are randomly selected within each major. Yep, stratified. The key there is we didn't eliminate any of the groups, right? I mean, each group at least had some effect there. I'm interested to see what you say for the next one. And I wrote it the way I did to see what you would say. Ah, very good. I was trying to push you towards which one, though? I was trying to push you towards systematic because I started with each student is assigned a number. You notice I said that earlier? Oh, each of you are assigned a number, 1 to 200. But then there, you pick somewhere to start. In stratified, you pick somewhere, or not stratified. Yeah, stratified, you pick systematic. You pick somewhere to start, and then you do every so often. That's not what it says here. It just says everybody's a number, randomly chosen. Does everybody in that population have the exact same chance of getting selected? They do. So that's a simple random sample. Any questions on any of those that we've done? As far as the vocabulary goes, this probably isn't the worst day. Right? Some of the other ones are a little bit harder. The key is to remember this is just one. This is the breakdown of just one of these, and that's sampling. Okay, there's not much you can do to break down a census. Right? Either you get everybody or you don't. Simulation and experiment, we're not going to deal with breaking that down as much either. Okay? Because sampling truly is going to be the most important.